Hello, I'm Anayallah Rampak Mayesha, and in this video, I will be explaining how artificial intelligence and expert system can help local paddy farmers overcome major agricultural challenges. Malaysian farmers today face several problems. Climate change is shifting rainfall patterns, weather is harder to predict, and labor shortages make farming more difficult. These issues put the nation's rice supply at risk. Fortunately, artificial intelligence, or AI, offers ways to improve productivity, reduce losses, and support long-term sustainability. So, how does AI work in paddy farming? First, AI can process large volumes of data, including weather forecasts, soil moisture readings, satellite images, and pest outbreak trends, to help farmers make better decisions. For example, AI systems can predict flooding or droughts, allowing farmers to prepare in advance. AI-powered drones or cameras can detect early signs of disease or pest infestations in the fields. Smart irrigation systems guided by AI can adjust water levels automatically based on soil and weather data, saving both water and crops. These technologies make farming smarter, not harder. Now, let's talk about the expert system. Another important tool. An expert system is a computer-based program that imitates the decision-making ability of a human expert. It contains a knowledge base and uses logical rules to analyze situations and provide recommendations. In farming, an expert system can guide a farmer on what fertilizer to use, when to plant or harvest, how to deal with pests or weeds, all based on the local condition. One example is the WIE3005 system developed in the Philippines. It's a web-based expert system created by the Philippine Rice Research Institute to help farmers make technical decisions. A farmer can input the location, variety of the rice planted, and growth stage. And the system will return recommendations like when to irrigate, what disease might be present, or whether fertilizer is needed. This type of digital assistant is especially useful for smallholder farmers who don't always have direct access to agricultural experts. In short, combining AI with expert systems helps farmers become more independent, accurate, and efficient in managing their crops. Now, let's move on to the second part of the question. What is the life cycle of an expert system, and which phase is the most critical? When developing an expert system, the process follows a structured lifestyle consisting of 7 key phases. Let me walk you through each of them. First, we begin with problem identification. This means clearly defining the issue the expert system is trying to solve. In the context of paddy farming, the problem could be farmers need help deciding when and how to apply pesticides to minimize crop loss. Second, we have knowledge acquisition. This is where we gather insights, techniques, and experiences from real human experts. In this case, agronomists, field scientists, and experienced farmers. Their knowledge is essential, as it forms the foundation of the system's intelligence. Third comes knowledge representation. Here, all the information collected is structured into something a computer can process, such as decision trees, if-then rules, or logic-based models. Fourth, we enter the system design phase. This involves planning how the system will function, its user interface, and how users will interact with it. Fifth is implementation. This is where software developers build the actual system, coding the rules, logic, and user interface. Sixth, we do testing and evaluation. We test the system with sample data to make sure it gives reliable, consistent, and accurate outputs. Finally, the maintenance phase. Agriculture is always evolving. Pests adapt, weather changes, and new practices are developed. The system must be regularly updated to reflect current realities. Now, among all these stages, I believe knowledge acquisition is the most critical. You might ask why? Because no matter how beautiful the system is built, it will be useless if the knowledge it contains is incorrect, outdated, or too general. If the rules are wrong, the decisions will be wrong, and that can cause real harm to farmers' livelihood. That's why this phase requires close collaboration with domain experts. It ensures the system reflects real-life farming conditions and not just theory. Without solid knowledge, even the best designed system cannot provide meaningful support.